Howdy everyone, this is Ari Danish with Side Effects, and today I want to talk to you about, well, an extension of the H17 Terrain Masterclass that I posted the other day. This time, we're still going to be looking at Heightfields and terrains, but we're going to understand the new Heightfield Scatter. So why a new Heightfield Scatter? Actually, a complete version 2.0 of it. Well, we wanted to solve two main problems. The first problem was non-moving scatter points when additional scatters are added. So imagine you just created your terrain and now you want to start decorating it. Probably the first pass you're going to do is place your major trees or villages, things that are going to be used for waypointing. So once you place them and you're happy with the placement, you don't want those points to be moved around if you do another scatter. So we solved that problem, and now you could do multiple scatters and have the previous scatters stay locked in place. Then we also needed to have a hierarchical scattering system. Why? Well, again, you're placing down villages or your major trees, let's say. And now you want to put down the bushes. You want to make sure that the bushes don't intersect your trees, or if you put down buildings, you want to make sure that no trees are growing through the buildings. So we wanted a way of making a hierarchical system where you could go from your large items to your small items without one, self-intersection, no use of placing points down that are going to have buildings intersect each other, and two, that if you have subsequent scatters for smaller things like bushes, that they're not going to intersect your larger areas. So an example of a hierarchy would be villages to buildings to trees, then bushes, rocks, and twigs. In addition to that, we want to solve for, well, think about a tree. A tree has two really radii. It has the trunk, which is kind of a hard radius that you can't penetrate. But it also has the canopy of leaves. And that canopy is high up, so you could place bushes or small sapling trees underneath the tree's canopy as long as it doesn't intersect the trunk. So we wanted a way to say what is the hard radius and what is the fall off. The other thing we want to do is, while scattering points at a certain level of the hierarchy, there should be controlled weighted variance. And let me repeat that again, controlled weighted variance. What I mean by that is, again, take the example of placing bushes underneath the canopy of a tree. It doesn't have to be just one bush. It could be 3 or 4 different types of bushes that are placed there. And that would be all at the same level because they're bushes. But what you want to be able to say is, I want bush 1 to occupy 60% of the placement, bush 2 to be another 25% of the placement, bush 3 to be 15%, and bush 4 maybe 5%. So you get this kind of organic blending of your bushes to make, again, the terrain look nicer. The other thing we want to do is make sure the scatter system wasn't locked to a certain level. And what I mean by that is, we could have said, hey, you get 5 levels of scattering. But that should be user defined. So HF scatter now is allowed to be cascaded. So you can put as many HF scatters one after the other you want, and each one will be your different level of your hierarchy. And it will keep 1, the height field, and 2, the previous scatter points, and use those points to determine where the new point should be placed. So I already prepared for us a height field so we can start playing with Heightfield Scatter. So I'm just going to drop down the Heightfield Scatter. And you'll notice now that it takes 3 inputs, 2 height fields, the green dots, and a geometry field. We'll talk about this a little later. The first one is just basically wire in your height field. And here I go. You can see that I got a ton of scattered points here. So let's create a mask. So we're just going to focus on a certain area. Well, we could go here now and we have mask paint. So I could go here and just pick a small area. And you can see as I am actually painting, I am getting that scattering going on, which is really cool. And I don't know if you just noticed, I added strokes. And let's see if I can just really zoom in here. And you can see that as I add strokes and I cross over, not much is changing in the old one. So it's locked down pretty good just by default. Okay. If I don't want to paint, I could do the old-fashioned way here. Let's just cut that out and go here and do a mask, for instance, by feature. And I could say anything, let's say a slope of 5 degrees to a slope of 16 degrees. And you'll notice that, man, not much happened here. I got points going everywhere in my scatter. Well, that's because I need to wire the mask into the second input. Once I do that, you can see now that I have it locked down pretty well. Okay, I'm going to do a third thing here. And just because I found for demonstration purposes, it's actually a lot easier to understand. Instead of a mask by feature, I'm going to go here and just draw a mask. Not very realistic what I'm going to do. Basically, it's just going to be a shape. But again, to understand the parameters of the scatter makes it so much easier. So I'll go here and just say, I want to make points in this area. Great. Okay, so let's wire in our scatter. And again, we got points going to be everywhere. Put in the mask. And now we're locked down just the area of the mask. So in the Heightfield Scatter, the first thing you'll notice is there's now a parameter called tag name. Tag name is going to basically be your hierarchy name. So is it village? Is it going to be buildings, trees, and so forth? And by default, it's set to $OS for operator string. So if I middle clicked on it right now, it would just say Heightfield Scatter 1. Let's change this to Heightfield Scatter trees. There we go, and you can see it just gets adjusted, just trees. Middle click on the tag name again, and it says $OS. The next thing you're going to notice is by the scatter method. We added a couple of new features, or new, features is a good word for it. By coverage using mask layer. So that means is depending on the amount of coverage, here we're set to cover the masked area by 0.5. And you can see if I decrease it, it's going to be a lot less sparse. And if I increase it to 1, it's going to be really a high density. If I change this from coverage to the next thing, density using mask layer, density is how much coverage per square meter do you want? And so now you can see that it says density 0.01. As I increase it per square meter, you're going to get a lot more trees. The third one is the total point count. So that's kind of like the default thing in a regular scatter. And the fourth one we'll discuss a little later, per point count using source points, which especially when it comes to creating trees and saplings under trees or bushes is really useful. Okay, so I'm going to go back here to by coverage using mask layer. So we already talked about what coverage does. How much do you want here? Then the next question is the outer radius. Now the outer radius, and I'm going to start zooming in so you can see what's going on. And even better, I'm going to put down a tube here with some end caps. And let's give it a color. I'll make it a green. And I'll copy to points so you can just see what's going on here. There we go. So let's put also a merge for now. By the way, this is not the way you're going to be doing it. I'm just doing this because we haven't discussed all the features yet, so we'll do it step by step. So just so you can see your terrain and the trees that we just laid down, here they are. And let's go back to that Heightfield Scatter. So the outer radius is saying, what is the outer radius of your hard limit of your tree? So right now my tube is set to a radius of 1. So if I say my outer radius here is 1 and my fall off is 0, you can see that I'm not getting intersecting circles at all. Okay, I might get circles that are going underneath the ground, but I'm not getting anything else. Now, what is the fall off then? The fall off is saying, what is the soft radius? I like to think of it as a penumbra when you put a spotlight down. It's what's that fall off from the brightest of the light to the gray area. So as I increase the fall off, that means other things underneath it can start to intersect a bit. With that, I should mention this parameter down here called relax points. If I turn off relax points, you'll now see that it's like a regular scatter, and I do get all sorts of intersections that I probably don't want. So I'll turn that off. The other one is self-overlap. Do you want to be able to intersect or not? So in the case of trees, it makes no sense to have any overlap. But if I'm going to be placing a bunch of boulders or rocks down, it might look good if they intersect and become, some are just individual rocks and the other ones are conglomerations of multiple rocks. And that's what this parameter self-overlap does. Okay, so now the next big thing after outer radius and fall off is the variability. We have lots of different ways of doing this. First one is uniform distribution. So if I were just to change this to 1 to 1, you can see now that every single circle is the exact same size of the outer radius of 1, or what I copied to my tube, which was again a radius of 1 here. What I'm saying here in uniform distribution is, what is my lower radius? Let's say, well, let's make it 0.25 so it could really exaggerate it. So now you can see I have some really trees with small, thin trunks. And let's make this 3. And some trees that are really huge. Now, as we get there, you're going to see that you are going to get some intersection. And that's because, again, of the fall off. If I really don't want that intersection, just increase the, or decrease, I should say, the fall off to something that will make sure that we don't self-intersect, like that. Okay, so that's uniform distribution. And again, the key thing about uniform distribution is that if I have a range of 0.5 to, let's say, 1.5, the average here is going to be 1.0. So the average size is going to be 1.0 with an even distribution between the minimum and the maximum of 0.5 to 1.5. If I change my variability from uniform distribution to normal distribution, things get more interesting. The default is set to 0.5, which means it's almost exactly like a uniform distribution in that most of the trees will fall off right in between 0.5 and 1.5 as far as size. And then it will slowly decrease to this minimum and maximum. It's no longer going to be a uniform distribution. Think of it more of a, like a bell curve type of distribution. But if I change this from a spread of 0.5 to 0, now you can see they're all the same size. So now we're saying there's no spread in this range. Find the mean, find the middle between 0.5 and 1.5, and make the trees all that same size. On the other hand, 0.5 was where we had almost a nice even distribution, a bell curve distribution of the sizes. If we start increasing this, what you're going to say is, I don't want the middle at all, or make it minimal, and put the probability of a tree at the minimum or maximum as the greatest factor in determining the tree size. So that's normal distribution. And then exact scale is that. It's just a scalar multiplier of whatever the input is going to be. Okay, so I'm going to change variability back to uniform distribution. And I'm going to actually make my tube a little higher as far as the height goes. So let's say maybe 5, just so we could see something here. And put the center here, relative channel reference, divided by 2. Just so we could see what's going on. Okay, so here's my little forest of trees. And go back down to my hierarchical scatter. And in my hierarchical scatter, what I want to show you next is, let's say I have this set to total point count using mask layer. And I really crank this up. So it's set to 93,000 points. Now, it's not going to be able to have that 93,000 points and yet a fall off of, let's say, 0, and it's still not being intersection, having any intersections. So what's going on here? Well, it's going to delete points. It's going to force itself to delete points that will cause intersections. So you could do one of two things here. You'll see there's a point removal method here. And the point removal method, you could either say remove or only flag. And you see when I change this to only flag, I get all those original points back. And they're all intersecting. But maybe you need those points for some other purpose. So how does that work? Well, let's go first to remove here. And I'm going to go and open up the geometry spreadsheet. So if I go here and spreadsheet, you'll see that hierarchical scatter sets up some really nice attributes for you. The footprint is, exactly how big is the radius of the footprint of each point. The fall off, right now I have a fall off of 0, so you can see each one of these is a fall off of 0. But if I increase this, you can see that I get them updated to 0.263 and so forth. Oh, this is a good point to bring out. Why do I have the first footprints here 0 and the first fall offs here 0? Well, this is by layer, okay? And if I go back to my hierarchical scatter here and go to information, you'll see that I have mass, bedrock, sediment, height, debris, and water. So what it's saying basically is I don't have that information for these layers here. It's only when I get to the layer that has all the scatter information do I actually have data for this. I hope that made sense. Anyway, so to get back to our point removal method. The point removal method right now is remove, so we're going to delete points. But if I change this to only flag, what you'll see is I have an attribute in my spreadsheet called remove flag. And you can see that some are set to 1 and 0. So the ones that are set to 1 are the ones that we would have deleted if we had this set to remove. But right now, it's just an attribute to say if you want to do further processing in the future, it's still there. Just know that we would have removed it if you needed it to be non-intersecting. So a few more parameters to get a handle on. Close the spreadsheet. We have a keep incoming terrain. So if you don't need the terrain, you just need the points, you can turn it off there. And that's really quite interesting because look at the output flag of our hierarchical scatter. It is a volume right here. But we're actually spitting out both the volume and the geometry all through this node. So by these parameters here, you could turn on and turn off what you want. Do you want the height field? Do you want the geometry? Or do you want both? So keep incoming terrain. The terrain is back. If you look at these guys, they're all at different angles. They're conforming to the slope of the terrain underneath. If I wanted them to be just basically Y up, I could change this match normals and turn it off. And now you can see they're all set straight up. With that, I could also randomize the yaw. And you can see, let's see if I can show you that here. And you can see, well, it's tubes. So you can see slowly that they are spinning. If I change that just temporarily to a box, you'll probably see it much better. Box. Ugly, but you can see it. Just look here and do Heightfield Scatter. And you can see that those boxes are turning. That's probably the easiest way to see it. And then randomize up is the same thing for the up. So if you want to get them to be in crazy directions, that's what randomize up is for. Okay, I'll just switch everything back to where it was, and then we'll continue. So I'll make this back to a tube. Heightfield Scatter, I'll make this 0 and 0 again. And yes, W, so we can see things here. Merge for now. That's good. Anything else I want to change? Okay, I think we can continue with learning about the parameters here. So I deleted the copy to points because if you remember, I previously said this is not the way I would do it. And now I'm going to show you how to set up if you wanted this all to be tubes. So the third input of the Heightfield Scatter, if I hover over it, is primitives to instance. So I'll just drop down here the tube. And I'll make it a polygon. I'm going to end caps. And then I'm also going to go here and do an attribute create. And I'm going to set this attribute create to an attribute called weight. And right now it's the only tube there, so I'm going to set its value to 1. And it's going to be a class primitive, not points. And I'm going to wire that in. And there's all my tubes. Okay, so let's see my Heightfield Scatter right now. I have a radius of 1, the fall off of 0.263. Let's make this a range of 0.1 to a range of 1. Oh, I forgot I have a total point count. That's why we are having intersections. So I'm going to change this from the scatter method from total point count using mask layer to by coverage using mask layer. And that's looking much better already. Okay, so that's really cool. And if I could do something that's also really nice is let's just put a color here. And I'll make this color green. And I'm going to put down a box. And the value here, I'm going to make the value, let's say, 0.7 for the tube. And I'm just going to bring this over. And if you don't know, just option drag for that is nice. And I'll make this weight of a 0.3 for the box. And I'll put it into a merge. Or maybe I should also add a color. Why not? How about a yellow? And then I'll do a merge. And this is not wired in, so let's wire it in. And voila, notice that we have the cylinders. They look about 70% of the cylinders and 30% of the boxes. If I go back here, I could change the weights, 0.5 and 0.5, and you get a pretty even distribution. If you're thinking it's not that even, it could be just because of the size here. This tube has a radius of 1, and the box has a size of 1, so that means the box is only half the size, so 2, 2, 2, and there you go. It looks now 50-50. And you can do this for as many as you want. I'll go here, just drop down a sphere, polygon, okay, let's make this 70, 0.1. Just make sure I didn't type in 70. Let's go 0.7. And here, 0.2. Color. And there it is. So if we now look at our Heightfield Scatter and go back into the geometry spreadsheet, you'll notice that there is an attribute here called variant. And the first few fields are by default set to -1. Those are your variants for the layers that are not having a hierarchical scatter, such as height, water, debris, and so forth. Then starting with where you have your scattered points, you'll have a variance of 0 here for your first input, which was the tubes. And we scrub down, you'll see that we have 1, for, I guess we did the boxes, and 2 for the spheres. So if you were to export this into your game engine, not only do you have a tag, and I should have shown you that earlier, we have a tag attribute called tag, and it is by that string called, in our case, HS trees. You can just pull up your trees and say, okay, I got to populate my game engine with trees at these points. And what variant do you want? Here's the variants. So you can have various different maples and oaks and firs and so forth being placed. Before I go on to show the hierarchical parts of the scatter operator, I want to show you a couple more parameters. So here we are in the hierarchical scatter, or I should say the Heightfield Scatter. And I'm going to go to the draw mask. The draw mask is a parameter called blur radius, and I'm going to just blur it out. And you can see as I increase the blur, the distribution of points goes along with the blur. And it's kind of nice that we have right now the highest concentration is where the highest values for the mask are, and as it slowly goes off to 0, our points go off to 0 also. But if we go back to HF Scatter, you'll notice that there is a parameter here called mask cutoff. And what I could do is I could decrease or increase it, and you should see points going on or off because it's saying if there's anything less than, let's say, 20% of a mask value, there shouldn't be any points. But it's not working. And I look and I realize that my point removal method, I forgot to turn it back from only flag to remove. Once I do that, you can see that my mask now has to be at 20% for it to distribute points. If I change this back up to 0.6, you can see that only the areas that have a strong mass value will have points distributed. For the next part, I simplified the network considerably. I just dropped it back down to a tube with a color, and I wanted to show you this parameter instance on new points. So that's what's giving you the actual tubes being displayed. And if you go to the information, you can see that it's already packing your geometries for you. Yeah, I'll do that again so you can see it's packing them to, I got 9,000 packed geos. Okay, so let's start doing something hierarchical. So I'm going to go here, and let's take my coverage way down. Just to a few, just like that. And I'm just going to drop down another Heightfield Scatter. So this guy again is asking for a terrain. And this one is asking for a mask. So we can use the same mask as we had before. And we get a bunch of geometry, and you can see that we have our little tree still there. So I could just kind of copy this just like that. Let's make it, why not, we'll keep it a 2, but we'll change the color to that nice fuchsia, and I'll bring it in here. You can see we got trees and we got our new scatter. Now what I want to show you is, and why I made it so few, is we have another choice now. When we go in and we have it now hierarchical, we can say scatter method by coverage using mask layer, but we can also say per point count using source points. And when we do that, what should be happening is going to first say what is the source point tag. In our case, our tag name was, from the original one, right here, $OS, which was HS trees. So I'm just going to copy that into our new place. And now you can see already that when we have the per point using source, it's going to start distributing these points around your original points. So imagine again the bushes around the central tree. And it's going to give us 2 per point count methods, a Poisson distribution or an exact number. So here I have an exact number of 10, 20, so forth around there. And then it's going to say here positioning method, offset, or origin. And you can see the origin kind of gives me a nicer kind of circle around there. The source origin radius, let's make it really tight so you see it's working. And you can see now I got all these points clustered around there. And the outer radius, as you can see as I move it out, they start to spread around those individual points. So that is really super useful. And again, if I go up to here to the Heightfield Scatter, the original one for trees, and I increase my coverage now that you can see it, you can see exactly what's happening here. Okay, so I want to show you one other thing here. It's now that I have a hierarchy of the green trees versus, let's call this the rocks here, HS rocks. Okay, I could do here relax points, and if you zoom in, right now relax points are turned on, so they're individual rocks. There's not much overlap. I see some because I really haven't zoomed in the min-max ranges yet, but if I turn off relax points, you can see how they all kind of now cluster around each other because they can overlap completely. And again, that would be okay if you want rocks to kind of smush together to make bigger rocks and smaller rocks, but just to let you know that it's there. And the other one is also self-overlap. If I turn that off, and let's see where I can show you that nicely. I'll look over here, I guess. Oh, here's a good example right in here. If I go self-overlap and I turn that off, sorry, X points. There, that's a better example of the clustering. Now these points can actually override for the self-overlap, but you can see it's still making that cluster circle around the origin, which can be quite useful, again, in different circumstances. Okay, I'm going to turn self-overlap back on. I want to show you something else also. If I change my scatter back to by coverage, that's doing a nice uniform distribution here. The key thing to notice is if I go and how do I want to do this? Let's do another draw mask. And I'm going to say, instead of replace, I'm going to say add to. And here I go. Notice something that's wonderfully happening here. I'm adding points, and the points of my new scatter points are changing because of the coverage, but my old scatter points are not moving. And that's really key here. We want to lock down the previous scatter. So in the parameters for Heightfield Scatter, if your scatter method is by coverage using mask layer or by density, it's going to lock down those points nicely when you draw or paint new parts of your mask. Nothing's going to happen to your old points. So I guess the last thing I should show you before we sign off is that even as you cascade, the variants still work. So I'm going to change that back to, because it's just cool, per point count, exact number. Let's make that like this. Actually, make it a Poisson distribution. And like that. Then I'll come here, I'll put a merge in. Change my weight here to 0.5. Option and an option. Again, as many as you want. Say 0.3, 0.2. Should put colors also. And it's still working just fine. And again, you can just keep on adding those hierarchical scatters any way you want, and it will work. So I hope you enjoyed this big overview of hierarchical scatter, and look forward to hearing if you enjoy this and what I should be doing next as far as terrain videos. Thank you so much.